All right, good morning, everyone, and welcome back. So, yesterday, we did the fundamentals of PowerShell syntax. Now, learning that syntax is very important, but learning PowerShell is a lot more than just learning the basics of the syntax and running scripts on the machine where you're sitting. Today is all about remote command execution. Once you have a script and you'd like to run that across 10,000 machines, how do you do it? So, learning PowerShell also means learning how to safely do things like this, but as always, power is a double-edged sword. If we can run a PowerShell script on 10,000 boxes, then so can our adversaries if they're able to steal our credentials. All right then, let's take a look at what's coming up in today's agenda. Section number 1 is on PowerShell Remoting using the Windows Remote Management Service and the WSMAN protocol. WSMAN stands for Web Services for Management. When people talk about PowerShell Remoting, then almost certainly this is the flavor of PowerShell Remoting that they're talking about. One of the benefits of using the WinRM service, the Windows Remote Management Service for PowerShell Remoting, is in Section 2, PowerShell GIA. GIA stands for Just Enough Admin. With PowerShell GIA, we could allow someone to remote into another machine, even though they're not a member of the administrators group. But when they execute commands, those commands are magically elevated as though they're members of the administrators group, even though they're not. If you come from a Linux background, if this sounds a little bit like setuid root, well, it is kind of similar. Again, by default, you have to be a member of the administrators group to remote into another machine, but we're going to see in section number 2 how to allow people who are not administrators to remote in, how to allow them to execute commands that are magically elevated without actually putting them into the administrators group. Now, of course, the trick here is how to do it safely. Well, that's what we're going to talk about in section number 2. There is another flavor of PowerShell remoting, though. It's SSH, authenticated and encrypted remoting, and that's what's coming up in section number 3. OpenSSH is the most popular and widely installed flavor of the Secure Shell protocol and service. OpenSSH in the past has normally been associated only with BSD Unix, Linux, and other similar operating systems, and in general not for Windows. There are third-party SSH servers for Windows, but until recently, it was never built into Windows. In fact, politically within Microsoft, there is even resistance to this. But now things have changed. Now, Satya Nadella is the CEO of Microsoft, not Steve Ballmer, and things have changed quite a bit. So the PowerShell team asked the leadership at Microsoft, can we have built-in support for SSH? And since Steve Ballmer is gone, well, then they said, yes, of course. And so that's what they've done. So recent versions of Windows have both the client-side tools installed by default, and for the server side, that's for the service or daemon, then no operating system currently installs that by default, but it's available for install. And all this is available in GitHub as well. So in section number 3, we're going to see how to install the SSH service on our machines. We have a PowerShell script for that, of course, how to configure it, how to use the client side, and we're going to see that PowerShell core is deeply integrated into SSH. Now, you don't have to use PowerShell to use SSH, of course, so we're going to see how to do that. But for the integration part, we're going to see that with PowerShell core, you could have PowerShell core as what's called a subsystem for SSH. That means you can remote into another machine, execute PowerShell commands, get XML data back, and then the XML data is, quote, reflated or converted back into objects again on the fly, just like with regular PowerShell remoting. Most of us work in mixed environments where you'll have a mixture of Windows, Linux, and maybe BSD machines. For example, if you have OpenNAS or TrueNAS, well then that's BSD under the hood, and it'll have SSH. SSH is also built into several other network-attached appliances. So learning SSH is pretty much mandatory if you work in IT or for security. And especially now that PowerShell core has deep integration with SSH, I think it makes it even more important for Windows people to know about it. We have lots of labs coming up in that section on SSH. Many Windows people have zero experience with SSH, and that is perfectly fine. That has just not been a traditional tool you find in Windows environments, but I think it will be. So we've got over 100 pages of material on SSH in the manual, lots of labs, in fact some of the longest labs so far. The labs that we did in yesterday's manual, well really, the whole manual was the lab. It was kind of a very long follow-along lab. Now, as we're into the middle of the week, we have more traditional labs where you do it on your own and at your own pace. PowerShell Remoting and SSH, though, are not the only ways that you can run scripts on thousands of boxes. We can also use group policy to execute PowerShell scripts, and that's what's coming up in section number 4. The difference is, if you're using traditional PowerShell Remoting with the WinRM service, or you're using SSH, you are actively reaching out and touching the target machine, establishing a TCP connection, and then executing your commands. Now, group policy, on the other hand, this is more of a pull architecture, where you wait for machines to refresh group policy, and then they download and run the script, or they download the scheduled task information to create a scheduled task to run the script. And in some ways, this is more scalable and fault tolerant than traditional PowerShell Remoting or SSH. Alright, so the theme of today is all about how to run PowerShell scripts across tens of thousands of boxes. PowerShell Remoting allows you to remotely execute commands, remotely execute scripts, remotely talk to the WMI service, we're going to talk about that tomorrow in particular, and also to upload and download files. So it's not just for remote command execution, it's not just encrypted telnet, so to speak. It's also remote script execution. We can talk to the WMI service and upload and download files as well. Now, this type of PowerShell Remoting has been around for a long time. This requires Windows PowerShell 2.0 or later, or any version of PowerShell Core. When you remote into another machine, the service that you're talking to at the remote box is the Windows Remote Management Service. And because that takes too long to say, usually we talk about that by its shorter alias name, WinRM. So WinRM is the name of a service that has to be enabled and configured at the target box. That's the service that we're talking to when we remote to the other machine. On Server 2012 and later, this service is enabled and configured by default. This means back at home, let's imagine that you have 1,000 servers that are running Server 2012 and later. By default, all 1,000 of them are listening for inbound PowerShell Remoting connections. Now, what about client operating systems like Windows 7 and Windows 10? The WinRM service is not enabled by default, but we can easily enable it through group policy or through a PowerShell configuration script. And that's the goal here. We do want to enable PowerShell Remoting across all of our machines, whether it's the WinRM flavor or the SSH flavor. Now, as defenders playing on the blue team, we can remote into any machine, execute scripts for hardening the box, applying patches, doing threat hunting, auditing, anything that we wish. Again, as I already mentioned, we're going to see all throughout these slides that this is a double-edged sword. If we enable PowerShell Remoting or the SSH service on all of our machines, if our adversaries are able to steal our credentials, then our adversaries will be able to remotely execute scripts too, like, for example, ransomware scripts. In fact, that's exactly what we're going to do on day 6. On day 6, we're going to pretend to be ransomware authors, and we're going to use these capabilities to run scripts on every machine in the domain. When you remote into another machine, by default you'll connect to TCP port 5985. So for our perimeter and host-based firewalls, we want to protect that port. If you install a TLS-compatible certificate, then you'll TLS encrypt the traffic, and you can optionally use a certificate on the client, such as in your smart card. Now in this case, you'll connect to port number 5986. So one strategy is to block access to port 5985 on every host-based firewall and perimeter firewall, only allow access to port 5986, and that's a way indirectly of forcing or requiring the use of a certificate and TLS encryption. Later on this week, we're going to install a certificate server. We're going to have a public key infrastructure, a PKI, and one of the reasons that we're going to set this up is to deploy TLS-compatible certificates to all of our machines for the sake of PowerShell Remoting, but also for other purposes too, like Remote Desktop Protocol. Now, who can remote in? You have to be a member of the local administrators group at the target machine, at least by default. So only local administrators can remote in. But we're going to see in the next section that we can change that default. We can allow people who are not members of the administrators group. But that's in section 2, and that is not the default. Now, what about the authentication then? When you remote to another machine, we have a variety of authentication methods that we can choose from. This includes Kerberos, NTLM, digital certificates, including your certificate on your smart USB token like a YubiKey or a traditional smart card. There's other authentication methods available too. Like for example, there's basic authentication. But just keep in mind that this is the same bad old basic authentication that we've had on web servers for many, many years. And basic, by default, sends your password in plain text. So if you are going to use basic authentication, which is not recommended, then you have to use some other protocol like TLS or IPsec to encrypt the password information. If your machines are joined to the same domain or trusting domains, then you can use Kerberos. That gives you a single sign-on, just like when you're mapping a drive letter or using an RPC tool. For standalone machines, you can use NTLM. But again, the most secure option is to use certificate-based authentication, and that's why later this week we're going to set up a PKI. Now, what if we don't have certificates installed? Does that mean all the data is sent in plain text? Is it all like basic? No. Even when you connect to port 5985 and you're not using certificates, the data is still encrypted. It's encrypted with an AES key that's derived from the authentication protocol. So this is important for understanding the hardening for all this. Depending on how you authenticate, that'll determine indirectly the strength of the AES encryption on the remoting traffic. So for example, what if I authenticate either with Kerberos or NTLM and my password is very short? Well, my adversaries then, they could intercept my Kerberos tickets, brute force crack them open, that would reveal the Kerberos session key, and that's the key that is used to share this remoting key. In other words, a user's short, weak password could indirectly result in the exposure in plain text of the AES key that's used to encrypt the remoting traffic. So later on this week, we're going to talk about how to harden or optimize the security of Kerberos. And again, one of the best things you can do to help make Kerberos more secure is either to use a smart card or at least a decent passphrase, like 15 characters long. The same thing goes for NTLM. In fact, NTLM, especially if you have the LAN manager portion still enabled, that's even less secure than Kerberos, and you're even in bigger trouble if you have a short password. For installing the certificate, we need a PKI. That's coming up later this week. But we don't have to install the certificate by hand. We can do that through group policy and PowerShell scripting. So we can enable later on this week something called group policy auto-enrollment. This is where we do a hands-free installation of TLS certificates on every single box, so every server and every workstation. Now, once you have a certificate on your machine, you have to configure the WinRM service to use it. This can be done by hand, and the steps are shown in your book, but it's far easier to script this out. And in fact, in your Day 5 folder, that's when we're going to talk about PKI, there's a script called Enable Remoting TLS, and that'll automatically identify a TLS-compatible certificate on your machine, and then configure the WinRM service to use that certificate. That way you don't have to do it by hand, and this is compatible with an automated way of installing and configuring these certificates on your boxes. Let's test it out. On your machine, please go to your first VM, that's your domain controller. Open up PowerShell ISE if it's not already open. And now please run enter ps session -computer name. The name of your other VM is member, and its full, there we go, and its full DNS name is member.testing.local. Now the testing.local domain, that's the default for DNS name resolution, so we can just type in member, and there we go. I've just remoted into the other virtual machine on my box. If this has failed for any reason on your computer, make sure that your other VM is up and running and that you ran the member server configuration scripts in yesterday's lab. So on page 11 in yesterday's manual, the second part of that lab, we ran some scripts on the member server to configure it. And those scripts, for example, modified the firewall rules so that you can ping that box and PowerShell Remote into it. So if you weren't able to remote into the other member server, please confirm that VM is up and running. As you can see on the left-hand side, the name of the remote computer is inside square brackets. So that's a visual reminder of where you're executing the commands. So if I start executing commands like, for example, get process, the command runs on the remote machine, and the output is displayed inside the command shell. To get back to your local computer again, just type in exit. You can also type the full name of the command, which is exit ps session, but just typing in exit by itself, that does the same thing. So that'll disconnect you from the remote computer and take you back home. So if you want an interactive command shell, similar to like good old Telnet, then that's enter ps session. You give the name of the remote computer, either the simple host name or the fully qualified domain name. If you are using a TLS certificate to TLS encrypt all the traffic and to authenticate the remote machine, notice in the middle of the slide that you have to use the Use SSL switch. Now, it's actually TLS, but Microsoft named the switch Use SSL because most people are more familiar with the term, with the acronym SSL than TLS. And there's something else too. Notice that when I connect to the remote machine, I'm giving the fully qualified domain name. Almost always, the TLS certificate on the remote computer will contain the fully qualified DNS domain name of that box. And when you connect, the name that you use to connect to the remote machine has to match the name that's in the certificate of the remote machine too. Once you connect, however, it looks exactly the same. So whether you're using, let's say, Kerberos inside the LAN, and then encrypting the traffic from a key derived from the Kerberos authentication, or whether you're going over the internet and authenticating with certificates, and then TLS encrypting all the traffic, once you have that remoting session, well then that command shell looks exactly the same. It doesn't look any different. Here's a nice trick. In PowerShell ISE, this is on your first one, please pull down the File menu and select New Remote PowerShell tab. So this is on your domain controller, your first VM. Go to PowerShell ISE, pull down the File menu, and select New Remote PowerShell tab. We saw yesterday that you can pull down the File menu and go to New PowerShell tab, and that opens up a new tab with a PowerShell session on the local machine. Now, by contrast, if you pull down the File menu and go to New Remote PowerShell tab, now you can type in the name of the remote computer. If you need to authenticate explicitly or manually, then you would type in your username here. But because we're going to use Kerberos as single sign-on, you don't have to type in your username at all. Just type in the name of the remote computer, which is member, and then click on Connect. Now, you get a new tab in the ISE editor. The name of the tab is renamed to match the name of the remote computer, and you now have a remote shell on the other box. So imagine that you're troubleshooting, let's say, interaction between 4 web servers and a couple back-end SQL servers. Well, in this case, you could open up 6 more tabs for those 6 machines, and then now you can conveniently switch back and forth between those different tabs. Once you're done remoting to the other box, then type in exit. That'll disconnect you from the remote machine. The tab still sticks around though. To get rid of the tab, just click on the X. The X on the tab will get rid of the tab. All right, so this is a nice trick then. In fact, you could even modify your profile script so that every time you open up PowerShell ISE, your script could detect whether this is the ISE editor as opposed to, let's say, PowerShell Core. And if it is the ISE editor, well then it could open up, let's say, another dozen tabs to another dozen remote machines. You could have this done every single time you open up PowerShell. I'm not saying it's recommended, but you could do it. Does the session stay open in the background if you close the remoting tab without exiting? Nope. When you terminate that tab, it terminates that PowerShell session, which then, as a part of terminating that, will terminate or log off, right, the remote sessions. Now, we are going to see in just a couple slides, though, how you can create a session to a remote machine, and that session stays alive. Now, even if you disconnect using, for example, exit PS session, that session will still be alive. Now, if you terminate the PowerShell process on your computer, then yes, the session goes away. So there is a halfway point as well. We're going to see how to create a session object in just a couple of slides, and that's about halfway between the two. So one command that we have for PowerShell Remoting is enter PS session. That gives you an interactive command shell on the remote machine. But here's another one. It's new PS session. You give the name of the target computer, the member server, and notice that the output of this command is saved into a variable on the left named $session. Now that session object inside the variable, that can be reused over and over again for many commands and many command shells. We can also use that one session for uploading and downloading files repeatedly. So once you have that session object in a variable, then all these PowerShell remoting commands, they all allow you to either establish a whole new session or simply use an existing session by passing in that session object as an argument. So let's look at an example. PowerShell Remoting is not just for remote command execution. You can also use it to upload and download files. So notice that to upload a file, you use the copy item command with the to session parameter. Now, that's to session, meaning for file upload. Now notice at the bottom of the slide, that's for file download. It says copy item dash from session. So it's to session when you're uploading files and from session when you are downloading files. Now in either case, whether it's to session or from session, notice that we are passing in that session object. And we can reuse that one session object that remains open the whole time. We can reuse that session object over and over again to upload and download files, execute commands, and get different command shells. It's important to notice the to session and from session part because notice the next parameters. We have path and destination parameters. But we have path and destination whether you are uploading a file or downloading a file. Now, if you are uploading a file, then the path parameter is followed by the path to a local file. And destination is where that file goes on the remote machine that we're uploading to. Now that makes sense, right? If we're uploading a file, it makes sense that path is local path and destination is at the remote machine. But keep in mind that at the bottom of the slide, when you are downloading a file and using dash from session, now the path parameter refers to a file on the remote computer. And the destination parameter, that gives the path on your local machine where you are sitting. That's where the file is going to be downloaded and saved to. How's all this data encrypted? Again, it's just like for anything else with PowerShell Remoting. It's either the AES key derived from your authentication protocol, or if you're using TLS, it's all TLS encrypted. You might look at this and say, well, this is so long and verbose. Are you expecting me to type this all in by hand over and over again for every single file? No, not really. I mean, you definitely can upload just a few files this way, but if you were uploading and downloading, let's say, thousands of files, all this would be rolled into a script. As we saw yesterday, you would use flow control keywords like maybe for each. For example, you might say, for each file in this folder, copy item to upload it to the server. So these commands can be long and verbose, but we're not always typing this in by hand. These are used in scripts with flow control keywords. And remember too that if you are typing it in by hand, please don't forget that we have tab completion. Let's create a session to our remote machine. So I've gone back to my domain controller. I've disconnected from the remote box. So notice that my prompt, it doesn't say member inside square brackets. If it does on yours, then just type in exit. Now let's create a new session to the remote machine. You can name the variable here anything that you want. So I'm doing $session equals new PS session. The name of the remote computer is member. But wait, how come my command prompt didn't change? Remember, this is not an interactive command shell. I now have a live remoting session to the remote computer. Information about that session is now stored in an object in the session variable. Now, what if I did want to remote into that machine again using enter PS session? This is what we saw on the prior slide. But notice, instead of doing -computer name and opening up a whole new independent session, instead I do -session. And I can give that session object. So now I've remoted into the machine using an existing session. You may not have noticed because these are just two virtual machines on the same computer, so it's pretty fast. But if you were timing this with a stopwatch, you may have noticed that this was faster. You actually connected back to the machine faster because the session already exists. So most of the time that it takes to establish a new session to a remote machine comes from the mutual authentication, checking the revocation status of the certificate, allocating a new run space, and in general, all the plumbing, right, that has to be organized and orchestrated for the remoting session. But if that session already exists, then you can just jump into it. Now I can type in exit. My remote command shell is gone, but the session is still alive. The session is still there. Until you remove that session, then it's still going to be there. Because we can upload and download files, and because we have support for all this built into the ISE editor, you can do a nice trick. Here we go. I've gone back to my virtual machine. This is on my domain controller. If you've closed the other tab for the member server, then please open up a new tab, new remote tab. So you can do File, New Remote PowerShell tab. You don't have to do this again. If you already have that tab, then just switch over to the tab. But if you've gotten rid of it, then do File menu, New Remote tab. The name of the other VM is member and connect. I've now remoted into that box. On that machine, notice that you have the SANS folder. And for example, this is day 2 of the week, and I can navigate into the folder for today. If I do a DR listing of my PowerShell scripts here, we can see that we have lots of PowerShell scripts in the day 2 folder. We're going to look at many of these scripts today. Now, one of the scripts that we have is named popup. We're going to play with that later on as well. So the remote machine is server core. I would like to edit a PowerShell script on the server core machine. Normally we would type ISE, but in this case we use a different command. We type psedit followed by the path to the script. Now remember, we've already connected to that remote machine. So when I run psedit and then I give the path to the script, we are editing that script on the remote computer. But we're editing it using a graphical app, PowerShell ISE, on the machine where we're sitting. Notice in the tab that just appeared, it says popup.ps1, but to the left of it, inside square brackets, it says remote file. So a common question is, if I'm using PowerShell on Server Core or Server Nano, how can I edit PowerShell scripts and remotely execute PowerShell scripts on those boxes? Using the psedit command, it downloads a copy of that script from the remote machine using PowerShell Remoting, not SMB. That temp file is opened up here inside your editor. If you make any changes to that script here inside the editor, well then that temp file is copied back to the remote machine and then overwrites the file that you are editing. Even more, this supports, for example, highlighting one or more lines and then clicking Run selection. But where does it run? Where does the command run? It runs on the remote machine, not the machine where you're sitting. So this is very handy. And if you click on the big green triangle button, or if you press F5, that will run the whole script, not just the highlighted lines. But again, where's that script running? Yep, it's running on the remote machine. Once you're done, click on the X to close the script tab. And again, you can either leave this member tab open with a remoting session to that box, or as before, you can type in exit to disconnect. So this is a very handy trick then. Imagine that you have 6 tabs open to like 4 web servers and 2 SQL servers, and you're running threat hunting scripts or auditing scripts or reconfiguration scripts or DevOps or something on each of those machines, but there's problems, there's bugs in the scripts. Well, it's kind of tedious then to download the scripts from each of the machines separately, maybe putting them into 6 separate folders because, hey, those scripts might all have the exact same name, and then edit the script and copy it back and remote into the machine. All that is very tedious and time consuming. So it's nice that this is built into the ISE editor. If you prefer using Visual Studio Code, this support is not built in by default, but there's a free extension for Visual Studio Code where you can do the exact same thing. And in Visual Studio Code, it can do it using SSH. So it's not just the ISE editor, Visual Studio Code can support it too. It's just not built in by default. Now we've just seen that we can use enter PS session to get an interactive command shell on a remote machine. That's great for human interaction, not so great for scheduled tasks or services. Imagine that you want to run a PowerShell script as a scheduled task. It needs to connect to a remote machine, but there's no human being standing around to interact with the blinking prompt or type in a password or anything. So how can you remotely execute commands and scripts without human interaction, without a human being looking at a blinking prompt inside of a command shell? Well, here's another command. It's called invoke command. So invoke command also uses the PowerShell Remoting service and protocol. You can use this to execute commands or scripts. So in the slide, if I run invoke command -script block, that's followed by, as we talked about yesterday, a script block. Notice that those are squirrely braces, not parentheses. If you want to have multiple commands inside the squirrely braces, separate each command by a semicolon. And then you give the name of the remote machine. Notice in this case, the name of the remote computer is in a variable. So that'll be common in your scripts. Very commonly in your scripts, you won't hard code the name of the remote computer. You'll have a variable, and then perhaps you're filling that variable with a command line argument or reading it from some other configuration file. Let's give it a shot. So I'm going to switch back to my domain controller. I don't want to use the member tab because that's for a live interactive session with the remote computer. So instead I go back to the first tab. Now remember that I already have an PowerShell session in a session object. I've already executed this command, and that session object is still there. It still exists, right? So if I look inside the session variable, it's not empty, it's not null. I've got a live session to the remote machine. And notice the state property here on the right-hand side. my session variable contains an object representing a live session to the other box, and underneath the state column or the state property, it says opened. So it's still there. So I'll do a CLS so you can see the screen better. Now I do invoke command. I could do -computer name and then type in the name of the remote computer. That's what's in the slide. But in this case, instead, I want to use the existing session. So I pass in that session object. I'll do script block, an opening squirrely brace, not a parenthesis, and then the command that I want to run. Like for example, I could do dir, which is the alias for get child item. Hit enter. Oh, interesting. Oh, there we go. So in this case, I ran dir and I didn't get any output. I wonder what folder I'm in on the other machine. Maybe I don't have permissions to that folder. So let me try it again. I'll give it the path to a folder I for sure have access to. There we go. That was interesting. So if you run just dir by itself, try giving the path to the sans folder instead. I think it did successfully complete. It's just that it outputted nothing. Now in this case, I did a dir of the sans folder, and now we can see all the subdirectories. You can run any command this way. Like for example, yesterday we ran get process over and over again, and the alias for get process is ps. On the remote computer, it's executing the command. All the objects outputted by the command are converted to XML. The XML data is sent back over the network to where I'm sitting, and the XML is used to recreate those process objects with their original properties. So this is part of the reason that we did the lab yesterday, where we ran commands and then exported the output of the commands to files on the drive. And one file type that's used are XML files. In a sense, that's what's going on in the background. You execute a command on a remote machine. The output are live objects in the memory of the remote computer. But I can't directly access the RAM or share direct access to the RAM on the remote computer like this. So instead, those objects are converted to XML. The XML is downloaded to me, converted back into objects, and then the objects are outputted on my local machine. I can display those objects inside my command shell, or I can capture them to a variable. Now, the reason I'm emphasizing all this is that when those objects are first created in the memory of the remote computer, those are live objects and they have methods. Now, on the other hand, when you convert object data to XML, and then the XML is downloaded, and then you create new objects in the memory of your local computer, well, what you have are called property bags. Yes, they are objects. They have the same properties as the live objects on the remote machine, but they don't have any methods. And we've now lost, so to speak, our live pointers in memory to those processes on the remote computer. Now, we still have lots of information about those processes, like the name and process ID number and path, and I can still do remote administration this way. But just keep in mind that when you convert objects to XML and save them to a file on the drive, like we did yesterday, or when you download it over the network, when you recreate objects out of that XML, you're getting what's called property bag objects. They have all their original properties, but they don't have their same methods. So going back to the slide then, when I use invoke command, I can give the name of the remote computer, and that'll establish a new session, and then execute the command in memory at the box. But that's with a new session. Or with the second command as showed in the slide, we can use the -session parameter and then give a session object for a session that already exists. The main reason I'm emphasizing this now is because of performance. Imagine that you need to run hundreds of commands or hundreds of scripts on a remote machine. If you have to authenticate, establish a new session, run the command or script, and then tear down the session. And then for your second command, you authenticate, create a new session, run the command, tear down the session. It's all that creation and tear down of the sessions. That's what takes a long time. So as a performance optimization trick, if you are going to run many commands or many scripts on a remote machine, first establish the session, save it as a session object, and then run all of your commands with that one shared session. And then when you're done, you can remove that PS session. It'll be a lot faster. Of course, if I'm planning to run dozens or hundreds of commands, maybe I should put those commands into a script. And in fact, in this case, you'll get even better performance. Notice in your slide that there's another parameter we can use, the file path parameter. That's followed by the path to a script. And now that script with all the thousands of commands inside of it, the whole script will be uploaded to the remote machine, executed at the remote box. And that's actually the fastest way of doing it. Whether you have a shared session or a whole new session, if you're going to run thousands of commands, probably better to put it into a script, copy the whole script in one shot to the remote machine, and then run the script at the target box. Now, in the first three commands I'm shown in the slide, the output of the command is simply displayed inside your command shell. But at the very bottom, we can capture the output to an array, in this case to a variable named $output. This is important for your hands-free scripts, like for scheduled tasks. Because now you could execute a script on a remote machine. If any of the commands in that script produce output, those are converted to XML. The XML is downloaded, converted back into objects. And where do those objects go? In this case, they go into the output array. Now, what was that funny name for those types of objects? Those objects that don't have any methods? Yeah, that's right. These are property bags, right? So these are objects that have properties, but they don't have methods. But nonetheless, we still have the same data. So what we have in the output array at the very bottom then are all the property bag objects that were created by running the script on the remote machine. And of course, in the rest of your script then, you could do something with that data, something useful. Yesterday, we saw how to create an array manually. So as we can see in the slide, it begins with @parenthesis, and then each item in the array is separated by a comma, not a semicolon. That's because this is a normal or regular array. Now that I have an array of command line arguments, notice that down below, I'm using invoke command to execute a script on a remote machine, but I have to pass in command line arguments. So here's another parameter, it's argument list, and I'm passing in the array of all the arguments. Now, very importantly, the order of the arguments in the array must match the order in which the arguments have to be passed into the script. So yesterday we saw the param keyword that you could have inside of a script. The param keyword would then be followed by a list of the variables that'll catch the arguments passed into the script. So if I have the param line at the top of a script, followed by, let's say, $X, $Y, $Z. So we have three variables, X, Y, Z. If I need to pass in three arguments, the order in which I pass in those arguments will determine which variable those arguments go into. But at least it's possible. In this case, notice that the script that we're running, this is from the day one folder, you have a script called send to syslog. That's a PowerShell script that can send a syslog packet over UDP to a syslog server, like let's say your SIM. But when you send a syslog packet, you have to pass in, for example, the IP address of the syslog server and other information like, for example, the facility, priority, and payload of the syslog packet. And that's what's being passed in as arguments. What if I have a variable in memory on my computer and I want to use that variable on the remote computer? So this is not a command line argument that we're passing to the remote machine. This is a variable in memory. So built into PowerShell is a command called getCredential. When you run getCredential, you'll be prompted for a username and password, or later on when we have smart cards, it can prompt you for your smart card and your PIN. If you've never seen it before, feel free to run it right now. Just run getCredential and you'll see the pop-up dialog box. the output is saved to a variable $creds. So this is the variable in the memory of my machine that I need to somehow copy into the memory of the remote computer. I want that variable to exist in the memory of the remote machine so that when I execute a command or execute a script, if that command or script refers to the variable, it'll find that variable in memory. Again, not in the memory of the machine where I'm sitting, in the memory of the remote computer. So here's the trick for this. It's a little bit of syntactic candy. I'm using script block just like before. Here's the command that I want to execute on the remote machine. And notice that that command is using a variable named creds. Now normally when you refer to a variable, it would be $creds. And if you did $creds, if that variable existed in the memory of the remote computer, it would work. But right now, that variable does not exist in the memory of the remote computer. How do you copy a variable in the memory of the machine where you're sitting into the memory of the remote computer? Well, as you can guess, it's with this special syntax here. It's using colon. So in this case, in between the $sign and the name of the variable, in this case creds, you put the word using and a colon. And that tells PowerShell to use that variable on the local computer. Now, what's going on underneath the hood? Underneath the hood, the contents of that variable are being copied in the background to the remote computer, where it creates a new variable of the same name, and the contents comes from the local computer, from the variable of the same name. This might not seem like a big deal, but later on, this is going to be extremely frustrating if you're not aware of the trick. Because after all, as we can see here on the top of the slide, I'm using getCredential to type in a username and password, but I need that username and password to go into the memory of the remote computer. Because at the remote computer, I want to execute commands and scripts that need those credentials. As you might imagine, that remote computer could be a jump server. So how do I get credentials from the workstation where I'm sitting into my PowerShell session at the remote computer so that the remote computer can use those credentials to then connect to further machines inside the LAN? Now there's a special way of using the using trick. Remember yesterday, we talked about a special type of an array called a hash table. Now please look at the bottom of the slide. A hash table is a special type of an array, and this begins with @squirrely brace. So on the prior couple slides, we saw a normal array that began with @parenthesis, but this is a hash table, so it begins with @squirrely brace. And as we talked about in yesterday's manual, every item in a hash table is actually a pairing. So on the left here, we have the key. To the right of the equal sign is the value for that key. Now in this case, the key is the name of a parameter, and the value on the right is the argument to that parameter. We're going to use the splatting technique that we talked about yesterday. But in this case, we're going to pass in a hash table of parameters and arguments using the splatting technique, but also using the using keyword. We're going to use using. In other words, we're going to copy that hash table into the remote machine's memory, execute a command using the splatting technique, but at the remote machine instead. So down at the bottom half of your slide then, we're creating a variable $splat. That's for a hash table. Now down below, we're executing a script block just as we did before. A script block also uses the squirrely braces. We're going to run getProcess. But as we saw yesterday, the getProcess commandlet has the -name parameter, and that name parameter can take an argument which is the name of one process, in this case the win init process. So down below, notice the difference. We're still using the using colon syntax, but to the left we have an @ symbol. By contrast, notice that up above, when we're just passing in a normal simple variable called a scalar variable, then we use a $sign. But because splat is a type of an array called a hash table is a type of an array, in that case the syntax is to use the @ symbol, then using colon, and then the name of the variable that contains the hash table. This means we can use the splatting technique to organize a complex set of parameters and arguments, not only for running commands on the local box, but also for running commands on remote machines too. Why do we have, like, for example, sometimes parentheses by themselves, or parentheses with an @ symbol in the front, or a $sign in the front, and under the hood, there's reasons for the weird syntax. Imagine on my local computer, I have a function named IP. And in fact, you do have that function. You can run that function right now in your command shell IP, and it'll display your IP addresses. But you want to run that function on the remote computer. Now, one way you could run a function on a remote computer is to put it into a script and then remotely execute the script. But there is another way of doing it. You can run a function on a remote computer by copying that function into the memory of the remote computer, and then the remote box runs that copy from its own memory. Now, the syntax here is a little bit weird. As we can see below, we have script block, just like on the prior slide. But now we have the word function, not the word using, a colon, and then the name of the function on the local box where you're sitting. But strangely, all this has to be placed inside squirrely braces with a $sign in front of it. And be aware too, there cannot be any space characters inside those squirrely braces. There can't be a space character at the beginning, at the end, in the middle, nowhere. If there's even one space character inside those squirrely braces, this will fail. Notice too that we're running a function on a remote computer, and we have the argument list parameter, just like we saw a couple slides ago, where you could pass in an array of command line arguments. And then the order in which the command line arguments are passed in has to match the order of the arguments that this function expects. Again, if they're passed in the wrong order, then it won't work. You'll get some kind of error message. Now, why the weird syntax? The weird syntax is telling PowerShell $sign is followed by something that should be treated as a variable. Now, in this case, is a variable that contains the code of a function. But nonetheless, you can do it. This means you could import a module on the machine where you're sitting. You might have hundreds of functions in memory now from all the modules that you've imported. And if you need to run one of those functions on the remote machine, you don't have to somehow copy and paste that function code from the module into a script, run the script remotely. Instead, I can just copy that function from my own memory into the memory of the remote computer and then run it at the remote machine. And I don't have to do all that copying and pasting. As we talked about yesterday, you can create an array by using the @ symbol, parenthesis, and then separate each item in the array by a comma. Now in this case, I have an array of 3 computer names, and that goes into a variable named targets array. But as we talked about yesterday as well, we have a built-in commandlet named getContent. You give it the path to a text file. Now let's imagine that that text file has a list of 5,000 computer names, each name on a separate line of the text file. Now, how did I get a list of 5,000 computer names? Well, maybe I queried DNS, queried Active Directory, maybe sniffing packets on the wire. If I got that list from Active Directory, though, I actually wouldn't have to save it to a text file first. As we're going to talk about later on in this course, I could use this command, get -computer-filter*, and that would connect to a domain controller, query for a list of every computer in the domain. That'll return back an array of computer objects. And of course, one of the properties of a computer object is the name of the computer. Now, importantly, one way or the other, I now have an array of 5,000 computer names. Either I created the array explicitly inside my script, Or I've got an external text file of thousands of computer names, or maybe I queried Active Directory to get that list of thousands of computer names. How can I run a command or a script on 5,000 machines? Look how easy it is down at the very bottom. So at the bottom, I'm using invoke command just like before, but instead of doing -computer followed by the name of one machine, the argument is an array of 5,000 machines. Now, what happens in the background on your computer when you do this? PowerShell spins up 32 threads. Each thread connects to a remote machine and executes the script or command. Once that command or script finishes running, and any output has been returned to you over the network as XML, that thread then disconnects from that machine and then connects to the next machine in the list. So that means by default, you'll have a live connection to 32 machines at a time. And as each thread does its work and finishes, that thread just simply goes to the next computer in the list. So one way to think about it is that if you have 5,000 machines and you want to run a command or script on all 5,000 of them, you do the first 32, the next 32, the next 32, the next 32, and so on. And you just keep cranking through that list of 5,000 computer names until you run that script on all 5,000 machines. Now, why is it 32? Well, that's simply the default from Microsoft. If you want to connect to, let's say, 128 machines in parallel, you can do it. You can change the default. Let's say they have one of those new AMD EPYC CPUs, and you could easily handle 128 simultaneous connections. So 32 is simply the default, but you can change that default. Notice in the command down here at the bottom, the output of running that script on 5,000 machines is all saved to one gigantic array named $output. Now, how much data can you gather this way? That depends on how much RAM you have and the size of your paging files or swap files. But that could be gigabytes of data. So when you're running a script that produces lots of output, and you're running that script on 5,000 machines, I mean, literally you might have to let this run for like 6 or 12 hours or something. And then when you come back, you'll have lots and lots of virtual memory allocated for that gigantic array inside the output variable. Probably you'll be better off running a command on a remote machine, getting the output of that command, and then immediately saving that as XML, comma delimited, or JSON on the local drive. That'll be a lot more fault tolerant. Because after all, what if your machine crashes at 99% progress, right? Then you lose all that data in RAM. So instead, imagine that you remotely execute a command, the script returns back to you a few kilobytes or megabytes of data, immediately save that, export it to a comma delimited file or XML file, and then connect to the remote machine. Now you come back, let's say 12 hours later, yes, you'll have 5,000 CSV files or XML files on the drive, but at least you have the data. And as we saw yesterday, you can use the import CSV command or the import CLI XML command to reread those files on the drive and then recreate those objects in memory to do something with the data. But it's a lot more fault tolerant if you write that data to local files as you're working away. One question is, if remote creds are stored in a variable on a remote machine, can't the creds be pulled from memory with Mimikatz or other hacking tools? Yes, they can. So those credentials are being copied into the remote machine. They can be scraped out of memory if the malware is running with kernel privileges, specifically the debug privilege. So that's one of the risks. And by the way, that's not just a PowerShell issue. We're going to see that that's an issue for almost all the protocols and services that we use in Windows for remotely authenticating to other boxes. So whether you're mapping a drive letter, using PowerShell Remoting, RPC tools, let's say for searching the event logs on remote machines, various different types of credentials are going into memory. For example, there's this type of a credential called a security access token. And once that security access token exists in memory, then tools like Mimikatz and other hacker tools can scrape that out of memory. So that's part of the double-edged sword of all this. Yes, it's very easy. In 2 lines of code, I could query Active Directory, get a list of 5,000 machines, and then in the second line of code, I could execute a command on all 5,000 machines. I can do it, and if my adversaries steal my credentials, like with Mimikatz, so can they. So this isn't just some average double-edged sword, right? I mean, this is a giant razor blade, with double-edged razor blade. So that's why later on this week, I'm kind of setting this up for you. I'm emphasizing the risks here, because later this week, we're going to talk about mitigations for these risks. Like make sure that you use, certificate authentication, smart cards, try to use local admin accounts instead of domain admin accounts. But that's coming up later this week. But yes, that is a risk. If 32 threads are producing output at once, would there be a problem with a file being opened while multiple threads are writing to the same file? Now, in this case, I'm imagining that each thread writes to a separate file, and then later we can consolidate all those temp files, so to speak. So if we have 5,000 machines, that might produce 5,000 CSV files or XML files. But once we're all done, and we are done remoting to all the other boxes, I've now got 5,000 files, and I can simply merge all that data together and then delete the 5,000 temp files afterwards. Not only is that faster, it also helps to get around that problem of file handle contention. Let's practice what we've just discussed. So the lab is on page 35. One question from the lab is, so what exactly is a secure string? A secure string is encrypted in memory, and only you can decrypt it. This uses something called the Data Protection API built into Windows. Why do we have to use secure strings? Like when we're creating a user account with a password or resetting a password, we have no choice. Microsoft's tools are simply designed so that you have to pass in a secure string when you do it. Now, how secure are these strings? Well, not very. Tools like Mimikatz and other hacker tools can scrape these secure strings out of memory. And in fact, you can decrypt your own secure strings without any hacking tools whatsoever. So this is more of security through obscurity. Microsoft's main intention is to make it more difficult for multiple users on one shared computer from accessing each other's secure strings in memory. So it's better than nothing, but it's not, a true, how should I put it? It's not like real security, like storing, let's say, a key on a smart card. In that case, you have hardware and firmware, right? Securing the secrets inside the smart card. But at least it's better than total plain text.